Stand up for the law. Stand up for decency. Stand up for compassion. Stand up for respect. Stand up for your community. Stand up for your future. Stand up for South Africa. LeadSA.co.za.
The Naked Scientist on Talk Radio 702 and 567 Cape Talk with Reedy Clubby.
Nick, I don't know where to start. Is it with this dreadful, treacherous weather that we're seeing on our television screens, or the announcement of the World Cup bid? That was also big news yesterday. How's the mood in the country right now?
Somber,
Okay.
I think you might say. We didn't do very well, did we? Only Australia got one fewer vote. We got 2 votes. They got 1 vote. And, well, I was listening to Australian radio, actually, Reedy. And the reason I was doing that is that I talk to the ABC in Australia once a week.
Right.
And they had a guy on before I was doing my bit of science stuff. And he was saying, well, in terms of football, it's great that it's going to Qatar because the facilities are fine and the players will have a great time. But what about the fans? I mean, everyone had a great time in South Africa because South Africa, let's face it, knows how to have a party. I don't think you can say the same, and this is what this guy in Australia, this football commentator, was saying about Qatar. He said it's a dry country. What are the fans going to do? It's 50 degrees C. He said it's the most unbearable temperature that you get there. It's intolerable. And you're going to have all these people with nothing to do, and they're going to not be able to go and get a drink or any refreshment, and it's going to be boiling hot, and there's nowhere for them to go. Players will be fine. Fans, not such a good experience, they don't think. So, no, I don't think it's such a good idea, really. I mean, it's fine to say let's give it a go, but I'm not convinced myself.
Okay.
I think it should come back to South Africa. South Africa do it again. They did such a good job the first time. I think it should just do it again.
That would be great. That would be great. And the weather, I mean, is it likely to let up any time soon?
Oh, our weather. Well, our weather's the complete polar reverse of what goes on in Qatar. It's freezing. It's about -4. And during the daytime, it's getting up to about 0 on a good day. Lots of snow everywhere. There are pop concerts being cancelled because fans can't get to concerts. There are schools being closed. So many people are saying, yep, this is Britain. One snowflake falls, everything melts down.
What a pity. It looks absolutely miserable. Tell us about worms, Nick. I hate them, but you're saying this new discovery may mean I may have to reconsider my aversion to worms. What's happening?
Well, the interesting thing about worms and other intestinal parasites is if you were to go looking around the world at who has allergies, who has autoimmune conditions, in other words, problems where the immune system attacks its own tissues, what you tend to find is an inverse relationship between people who've got parasites and people who have those conditions. In other words, if you look in third world parts of the world where sanitation is poor and people tend to carry intestinal worms particularly, you don't find many allergies and you don't find many examples of inflammatory bowel diseases like Crohn's disease and ulcerative colitis. So why is that? Well, it's probable that the worms are secreting something into the wall of the intestine to stop the immune system getting rid of the worm, and this is how they survive. But under certain circumstances, you can also use this cunning observation or the effect of these worms to treat certain diseases that are inflammatory, which is exactly what appears to have happened in this paper which has been written up from America. It's by Mara Broadhurst, who's a researcher at UCSF, and it's in Science Translational Medicine this week. And it tells the story of a 35-year-old man who has ulcerative colitis, one of these inflammatory bowel diseases, which is very unpleasant. It causes people to develop bloody diarrhea and pain, and you get inflammation of the large bowel, and it can be a risk factor for getting cancer if it's allowed to continue for any length of time. And there are drugs that can damp it down, but inexorably it usually keeps on getting worse. And this 35-year-old man was offered the option to have a colectomy, at least part of his intestine removed, to try to treat the disorder. And he declined, and instead decided to swallow the eggs of 2,000 roundworms, Trichuria, Trichuris roundworm eggs. And within a very short space of time, all his symptoms went away. And the researchers did a telescope test looking inside the bowel, and they took some samples from the bowel lining, and they then examined those. The man remained well for 3 years, And then his symptoms came back again, and the researchers found that the number of worm eggs that he was shedding in his feces had dropped, indicating that the number of worms he was carrying had lowered a bit. So he then took some more eggs, another 2,000 eggs of this roundworm, and all his symptoms went away again. And this was confirmed when the researchers looked inside the intestine, took samples again. So, this is a very unusual study which has given someone the opportunity to do proper scientific experimentation on how a disease, an inflammatory disease, responds to an infestation of worms. And what they found when they examined the biopsies from the bowel lining was that the worms seem to be making the immune system change the production of different immune signaling chemicals. So in worm-infested bits of the gut, there's a high level of an immune signal called IL-22. And this signal seems to provoke the lining of the intestine to grow faster and repair itself better, and also to produce more mucus, which helps to protect the lining of the intestine. Now, as an anti-worm strategy, this is very good because it helps get rid of the worms, but actually it has the side effect of making the ulcerative colitis get better. And so this is one of the first and unique examples of people being able to track in real time what changes the worms are inducing in a person's intestine. And the long-term goal of doing this kind of thing is to try to provide a way or come up with a way to mimic what the worms do without having to infect a person with worms. So it's just lucky that this person decided to go down this route of infecting himself with human worms in order to make an inflammatory bowel condition get better.
All right. Chris, somebody has just pointed out to me that I called you Nick. You see, I've got a comedian who comes in every Friday. His name is Nick. I'd like you to please give me a scientific explanation as to what on earth I was doing.
We did it twice, actually, but in the standard way that we do on the radio, when someone does something like that, the first thing you do is not draw attention to it, because the likelihood is most people didn't notice.
They do,
Unfortunately, you've now shot yourself in the foot, really, but...
No, they're sending me SMSs. They say, really stop calling the Naked Scientist Nick. Really stop calling Chris Nick. The SMSs are just... I wasn't even aware I've done it, so I wonder where my brain could have been.
Actually,
Apologize.
I was wondering whether it was me, because I was thinking... Have I got up this morning and I've had some kind of mental aberration and I am called Nick, but actually I thought I was called Chris. And so I didn't like to say anything, just in case it was me. I don't know why this happens, but I think it's that we have this amazing brain which is very good at filling in gaps for us and putting you onto autopilot so that things occur subconsciously and automatically without you having to pay lots of conscious attention. Unfortunately, if the wrong bit of information gets put into that process, you then don't notice until it's already happened. It's a bit like driving. Because I noticed, someone said to me the other day, I was actually talking to Rick Wakeman, who's a keyboard player, very, very famous, and if you want to look him up on YouTube, I've actually been to see him play. You can't play faster or as fast. No one can play as fast as Rick Wakeman. But he always plays these amazing pieces of incredibly quick music with his eyes shut. So I said to him, why do you want to play with your eyes shut? How do you see what you're doing? And he said, well, if I look, I go wrong. He said it's like driving. You drive down the road for a bit. Not that he drives with his eyes shut, but
thank goodness for that.
You'll suddenly think, I've just driven for 5 or 10 minutes, and I can't remember anything about doing it. And it's obvious that you're on a sort of autopilot and you've gone round roundabouts and negotiated traffic junctions and things, no memory of it. And this is all occurring at an automatic level, so you can put the conscious part of your brain onto doing more important things. And probably what goes on is when you get very well acquainted with doing something, occasionally these slips happen because you get the subconscious bit of your brain doing that to make it able for you to think about things, and you don't notice when you're making a slight error.
Okay, sorry about that. Okay, we're taking your calls on 021-446-0567, 011-883-0702, and Charles in Roodepoort. Good morning.
Good morning, how are you?
Fine, thank you.
Yeah, hi, Nick.
Hello, George, how are you?
Okay.
Yes, Charles, what's on the mind?
Chris, have you ever heard of something called kangaroo mother care?
No. Tell me more.
Well, okay, basically what it is, it's a way of caring for a newborn infant, especially underweight infants, where the neonate is placed on the mother's chest or the father's chest, where there's skin-to-skin contact, and it is shown, in the journals I've read, to be there's much better development, much less a chance of infection, the vital signs are stabilized, and there's more satisfaction for the infant and the mother. Now, those facts are there. I'm just wondering why that is. You know,
Are you referring to when the baby first pops out, that it's immediately put onto the mum or dad's chest rather than taken away and had things done to it? Is that what you mean?
No, they say if you put it, the earlier it's initiated, the better their effects. But it's not just initially; it's protracted, and.
Yeah, I'm not that surprised though, really, Charles, because for two reasons. One is a purely it's evolution type reason. We don't necessarily have to explain something scientifically to know that the fact that it works means that evolution, because we've been around for so long and slowly we've selected for things that and behaviours that do have a benefit to us, that's probably part of it in terms of the fact that there must be a tangible benefit. And two, we know that the mother gets enormous benefit through having a baby put straight up onto the chest when the baby comes out, if that's possible. Because, for instance, if a baby suckles straight away, although not much milk will come out, what it will do is to make the mother's brain produce the chemical oxytocin. And oxytocin, A, makes milk come out later, B, it makes the uterus contract to make sure that the third stage of labour, the placenta coming out, happens smoothly, and also that there's reduced blood loss. But also, this is critical for mother-baby bonding, because the release of oxytocin makes one person trust another. And I would suspect that perhaps the reverse is also happening in the baby, that the closeness, the apposition of the baby to the mother is good for reducing stress in the baby, because it's very stressful being born. So you've got this warmth, you've got a familiar, a smell that becomes very familiar, a closeness and a warmth that again makes you become very familiar with that person, and so the baby bonds to the mum as well. And we know those early minutes are critical. And if you reduce the stress in the baby and make the baby feel happier, it's going to do better, because it's going to eat better, it's going to sleep better, and therefore it's going to grow better.
All right, let's go to Barris in Bloberg. Hi.
Good morning. Now, just a question. You know, I look at my children. Now, it's my wife and myself producing the children we got. Yet they're so different in character and looks and all that. What is it the sperm cell that is in an individual with its own characteristics that makes the difference? You know, I understand that twins or sometimes twins or than that, but what is it about a sperm cell that makes the individual so different?
Hello, Peter. Sorry, I think the joke's run out now. I'll stop doing that. I'm just joking. The answer is that when you make sperms and eggs, the genetic material from inside your stem cells, the germ cells that are going to make the sperms and eggs, get shuffled round. And you've got two sets of every chromosome in your body. So you have 23 pairs of chromosomes, 22 of them are called autosomes, they're the main non-sex chromosomes, and they come in pairs. So there's 2 chromosome number 1s, 2 chromosome number 2s, 2 chromosome number 3s. And the reason there's 2 is because you have one from mum and one from dad. Now, when you make a sperm or an egg, what happens is that you divide the chromosome number in half. So you say, well, I'll have chromosome number 1 and I'll have the one from dad. I'll have chromosome number 2, I'll have the one from mum for that one. I'll have chromosome number 3 and, well, let's have dad's one of those. That happens to start with, so there's already independent assortment of the chromosomes. And also, when the chromosomes are being shuffled in this way, they also swap bits of information between themselves. They do what's called crossing over. So chromosome number 1 can swap some of its genetic material with chromosome number 1 from mum. So dad and mum's bits of chromosomes can also swap over, introducing further variability. And because the same genes are found on the chromosomes in the same places, so you get a complete set of all the genes, but you shuffle up which parent is contributing which genes, you end up with enormous levels of variation in the genetic material that you pass on into the sperm. So the sperm has got half the genetic information, the egg has got half the genetic information required to make a person. When the sperm goes into the egg, you then end up with a new cell with 23 pairs of chromosomes again, 2 of which are going to be the sex chromosomes, X and Y or XX, depending upon whether you're having a man or a woman baby. And then you've got these other 22 pairs which have now had their genetic material shuffled up. And so that variation is what then leads to variation in the development of the individual at a genetic level. So genes control how we develop and what we look like. And there's also an element of chance during development in a number of ways. One is just that you're rolling dice and things are developing in a random way. That's part of it. And the other is that there are genetic elements in our DNA that can move around. They jump. They're called transposons, and they can jump around into different bits of the genome and change the behaviour of different bits of the genome, and that introduces further chance and uncertainty, and therefore further variation. So it's fair to say there is no one, apart from your clone or your identical twin on Earth, who is like you. Every individual is unique genetically.
Thank you very much, Beres. Let's go to, is it Judy? Judy in Sunninghill. Hi.
Hi, Chris. Chris, what I want to ask you is, you often hear that the capacity of the brain is limitless. But do we actually know any idea of the capacity of the brain to be able to make that statement?
Hello, Judy. No, we don't really know. We know that the brain is incredibly powerful. We know that it can hold enormous amounts of information, but it's very hard to put a number on that. There's a difference or variation between individuals, but also there's the faithfulness of memory. Because when I plug a memory stick or something into my computer, or a USB pen drive or something, I make a faithful copy of the data, hopefully, that's on the computer going onto the drive. And then if I take that pen drive to another computer, I get a faithful copy of the data off. But human memory doesn't work like that, because our brain invents the scene for us using a few kind of clues from what we've chosen to remember. So when I ask you to imagine or think of an event that's happened to you in the past, there'll be a few key facts that you know for sure happened in that occasion, and the setting you'll be acquainted with. But the periphery, what else was going on there, what things looked like, your brain is making up. And so we don't know exactly how much the brain makes up and how much it remembers verbatim. But the bottom line is that the brain is so powerful and can do so many things that it would be a very, very big and very expensive to computer to replace it. And the other point is that it's incredibly efficient, because the brain burns off energy at the rate of perhaps, I think probably the average 70 kilo person's probably running at the rate of about 150 watts, and the brain accounts for 20% of that. So your brain is probably burning off energy at the rate of 50 watts, so about a light bulb's worth of energy. Your computer on your desktop is probably using 500 watts, so 10 times more, and can only do a fraction of what your brain can do at the moment. So the brain is a very powerful machine which is incredibly energy efficient.
All right, Chris, let's talk about this drug that can wipe away pain memories. I can think of many people who'd line up for that one.
Well, there's a paper that's been published this week. It's in the journal Science, and it's by Zhan Yao Li, who's a University of Toronto researcher. And they were interested in the concept of something called neuropathic pain. Because when we get nerve injuries, some people develop chronic pain states where a part of the body becomes very, very sensitive. So where normally just stroking the skin would feel like light touch, for these people it becomes extremely painful, almost excruciating. It's called allodynia. And you can make this happen in a mouse or a rodent by injuring a nerve, and you get a mouse equivalent of this condition. But these researchers wondered, well, what's going on to make this person have this hyperalgesic state? So they used a mouse that had been genetically modified so that when nerve cells become damaged in the body, they glow green. And they injured the common perineal nerve of a small number of mice, and then they looked in the brain to see if there were any cells in the brain that were glowing, indicating that they too had changed their behaviour secondary to the injury. And they found some cells that were glowing in a part of the brain called the anterior cingulate cortex, which is at the front, and it links your higher executive brain functions with your more vegetative and automatic functions. And what they did was to then look in this area to see if there were increasing levels of a signal called PKM-zeta, which is phosphokinase M-zeta. This is an enzyme that seems to be involved in strengthening connections between nerve cells. And as it happens, there is a drug which has been made that can inhibit this enzyme, which goes by the sexy name of ZIP, Z-I-P, because it stands for zeta pseudo-substrate inhibitory peptide, ZIP. And if you give this ZIP, it blocks this enzyme from working. And if you inject this ZIP into memory parts of the brain, you can wipe out memories. It just deletes the connections between nerve cells. So they reasoned, well, perhaps this pain is the brain remembering something too well a painful stimulus, and that's why people feel in pain all the time. So they injected some of this zip into this anterior cingulate cortex where these cells were glowing green in response to the injury, and the mice in the experiment went back to behaving like mice that didn't have any pain at all. And so this suggests that in future we may be able to use this memory wiping clean strategy, this zip drug or drugs like it, to delete memories of painful things, and this may make the pain go away. And there are lots of examples of human conditions which this could really help with things like phantom limb syndrome, where people have, say, an amputation and they then develop terrible vice-like chronic pain in the missing body part, and it's very hard to treat at the moment. Perhaps with this strategy that would become amenable to therapy.
Let's go to, is it Kalia in Norwood? Hi.
Good morning. Morning, Reedy. Morning, Chris. Thank you for a very interesting show.
Thank you.
Is there any scientific reason why we get songs stuck in our mind? In my case, and I'm sure for a lot of other young parents, particularly Barney songs.
And it's usually
I was going to
songs
ask you,
that
what
I
have you
don't
got going
like.
around in your head right now?
Yeah.
It's a lovely question. These are referred to as earworms in the industry, and actually everyone seeks to create one, because if you've got Kylie Minogue or whatever going around in your head 15 times a day, unpleasant as that sounds, or maybe not.
Not.
Then it means that you tend to go and tell people, oh, I've got this Kylie Minogue song going around in my head and I can't get rid of it. And then it's really good branding for the music. People tried to get some insights into this recently with a really elegant series of experiments. And what they did was to put people in a brain scanner, they played them a piece of music, and they watched which bits of the brain began to respond to the music. They then introduced a gap in the music. So you have the music pausing for a fraction of a second, or maybe for 10 seconds, 30 seconds, and then they resumed playing the music. And what they were asking the people in the scanner to do was to let their brain relax. When the music stops, if they experience the music carrying on playing like their brain was filling in the gaps, then to just enjoy the music that they were hearing in their head, and then the song would resume later. And why this is critical is they were watching which bits of the brain do the active listening to music, and then seeing which bits of the brain change when the patient or the person says they are imagining the song in their head. And what they found is that there's an area called the visual cortex, the auditory cortex, which is where you decode sounds, and the primary auditory cortex turns on. There are nerve cells that become active there when you're listening to the music. But then adjacent to that is an area called the auditory association cortex, and this is on the surface of the brain, and that turned on very strongly when the music stopped. And this is when the people were imagining the song continuing in their heads. So when you have an earworm, what probably is happening is that these regions of the brain which decode sounds are being fed with your brain's own creation of what it knows is how the song goes, and it is feeding that into the area that you normally hear the song with actively, making you think you're hearing it, but of course you know you're not really hearing it because you know you're making it up inside your head. And exactly why it keeps on going round in a circle, no one actually knows, except to say that it is very, very annoying, and the only way to stop it happening is actually to stop obsessing about it, because if you keep on noticing it and you keep thinking, oh, this is so annoying, it will happen more, because what you're doing is reinforcing the pathway that makes it happen. And the best thing to do, in fact, I asked someone who works on this scientifically, and he said the best thing to do with an earworm is to replace it with another one. In other words, when you're thoroughly sick of the one that keeps going around in your head, try and find something else and listen to that, and then that will go around your head instead.
Okay, good luck to you, Kalia. Good luck. My colleague asked me to ask you, Chris, about the leak of NASA's data, which confirmed that there was some type of bacteria that managed to live and survive despite high levels of arsenic. What does this mean? What are the implications of this? Because we've always known that the conditions of life are unique and specific, but this time around, does this show that life can happen despite these levels of arsenic? Tell us about that.
Well, I'm actually looking at the paper right now. It's come out in the journal Science. It was released last night. Felisa Wolf-Simon is the author, and she actually works for NASA's Astrobiology Institute in California. And this is a very interesting paper because it's a piece of work which is based around a lake called Mona Lake in California. And what the researchers have done is to identify and discover bacteria. It's a species or a strain of bacteria called Holomonaceae. And these bacteria live in water and they are capable of tolerating very high levels of arsenic, because in this lake it's a very strong salty solution, but it's also very rich in high levels of arsenic. And the significance of this is that these bacteria appear to have evolved to tolerate this high level of arsenic, but also to replace some of the normal essential chemical building blocks that we think are critical for life with arsenic. Now, critically, the one they've done that for is phosphorus, because we think that there are 6 big players in life. There's carbon, hydrogen, oxygen, nitrogen, sulfur and phosphorus. And phosphorus does all kinds of really key jobs in the body. It's used to signal things, it's added to enzymes to turn them on and turn them off, and it also forms part of the backbone of our DNA, our genetic material. But if you look at the periodic table of elements, phosphorus is just above arsenic in the table, and that means that the two things are slightly different sizes, but they do relatively similar chemistry. And what these bacteria do, it would appear, is substitute arsenic atoms for phosphorus atoms in their chemistry, and they can do that perfectly easily, because the researchers took a sample of this water from the pond, this lake, they grew the bacteria in a culture environment, and they then slowly replaced all the phosphorus in the growth medium with arsenic. And the bacteria started growing perfectly happily. They grew slower than they did with phosphorus, but they could grow with arsenic. And they replaced all of their lipids, proteins, their DNA, phosphorus, with arsenic. And this says that life doesn't just have to revolve around these 6 magic elements, because even here on our own planet, we've managed to find an example of bugs that can totally change the chemistry of life. And this makes the prospects of finding life and complex life somewhere out there in the universe, elsewhere other than on Earth, much more likely.
Very fascinating. Chris, as always, a pleasure chatting to you. We'll do that again next week. Bye-bye.
Yeah, thanks, Reedy. Have a great weekend.
Bye.
And, yeah, wish me luck in the warm weather.
Oh, survive it. Please survive it.